Hello everybody, today we're going to look at using Pascal's triangle to simplify powers of binomials. This you might also seen written as the binomial theorem. Today we're not going to look at its applications in probability, but it does have applications in probability, and that's its most important application. Today we're just going to look at how to simplify it, how we're going to use this kind of stuff to simplify polynomial expressions. Later this year we'll look at the probability aspect of it all. Okay, so the first thing we need to look at is Pascal's triangle itself. So you look at the rows here, right? And for example, you'll notice that it starts counting at row 0 where it's just a 1. These rows are representing different exponents, okay? Row 1 is 2 1s, right? Row 2 is 1 2 1. You'll notice that the 1 here and the 1 here, they add to 2. The 1 here and the 2 here, they add to 3. The 2 here and the 1 here, they add to 3, and so on. So we're just going to fill in the rest of the triangle using that pattern. I have a plus b squared here, so I'm going to look at row 2, which is 1 2 1. These are telling me the coefficients. So the numbers inside the triangle are telling me the coefficients. So I'll have 1a squared plus 2ab plus 1b squared. So I start with an a squared and I descend in exponent value. So I go from 2, 1 to no a exponent. And then I go opposite with the b's, right? So it starts with none, then I have 1b, and then I have 2b's. You'll notice that the exponent between both variables, a and b, or both stand-ins here, because they're variables, but really we're going to have something in these placeholders, right? You'll notice that they always add to 2. So in the first one I have 2a's, and then I have 1a and 1b, and then I have 2b's. All right, let's try this again. I have a minus b to the third power. So I'm going to look at row 3, which is 1, 3, 3, 1. Those are my coefficients. And now, a cubed, a squared b, ab squared, b cubed. Now, a cubed, a squared, a, no a at all. It's counting down as we progress, and b does the opposite. No b, b, b squared, b to the third. So it just flip-flops. And you'll see that a cubed, a squared, and b, that's a total exponent of 3. A, b squared, that's a total exponent of 3. And b cubed, that's a total exponent of 3. I just need to figure out the signs of everything. So the first one is obviously positive because a is positive and a cubed would therefore be positive. But here I have a squared b. A squared is positive, 3 is positive, but b here, you'll recall, it's minus b, so that's a negative number. So this will be negative. Here, I have b squared, so the two negatives cancel out and make a positive. But on the next one, I have b cubed, and a negative cubed is negative, so I have a minus sign again. Okay, last one before we do actual examples. I have a plus b to the 6th power. So I'm looking at the 6th power, so I go to row 6. Row 6 is 1, 6, 15, 20, 15, 6, 1. We'll kind of ran out of room here, but we'll be okay. All right, so I have 1, a to the 6th plus 6, a to the 5th, b to the 1st, plus 15, a to the 4, b squared, plus 20, a to the 3, b to the 3, plus 15, a squared, b to the 4, plus 6, ab to the 5th, plus 1, b to the 6th. And there you go. That's how you set this up. And I'm going to show you how I would actually do a problem handling one of these. So if I have 3x plus 2 to the third power, this is just a shortcut. You could triple distribute this. Do 3x plus 2 times 3x plus 2 and get 9x squared plus 12x plus 4, and then multiply that by 3x plus 2. You can totally do that, but especially as we get to larger exponents, that gets tiresome. So here, I have an exponent of 3, so I'm going to go to row 3, which is 1, 3, 3, 1. And I like to start writing this vertically so I don't run out of room like I did with that a plus b to the 6th power. So 1, and then I'm going to have 3x, and it's going to be cubed. That's my a and my b, right? And then I'll have 3x squared. I'll have 3x to the first power, and I'll have 3x to the 0 power. Then I'll have 2 to the 0, 2 to the first, and then I'll have 2 to the second, and 2 to the third. And I kind of figure out what each one of these little terms is on their own, and then I write them in standard form at the end. So in this first one, 3 cubed is 27, so I have 27x cubed, because I don't have to multiply it by anything else, except for 1, which is obviously the set itself. Here, 3 squared is 9, times 2 is 18, times 3 is 18 times 3 is 54. And that x gets squared as well. Here I have 2 squared is 4, times 3 is 12, times 3 is 36, so this is 36x. And here I have 1 times 2 to the third, which is 8. So my answer is 27x to the third plus 54x squared plus 36x plus 8. Alrighty. We can do the same thing with 5x minus 4 to the 6th power. So 6th power, I look at row 6, which is 1, 6, 15, 20, 15, 6, 1. Obviously, if you needed to use a higher power of a higher exponent here, you could expand the triangle just by kind of... And you don't even need to draw the hexagons. It's just to help space, is all we're doing here. And you could fill it in, right? But we don't need to. We're going to use the 6th row. So I'm going to have 1 times 5x to the 6th, and then I'll have 5x to the 5th, 5x to the 4. I'm going to cut right here and just finish filling this in. All right, so now I figure out what each one of these statements is. So I'm going to bust out a calculator because I don't actually know all of these off the top of my head, and I don't think you do either. And that's okay. That's why we have calculators, right? So I need to do 5 to the 6th power, which is 15,625, and then I'll have x to the 6. Everything else is 1, so I don't need to worry about it. Now we need to do 5 to the 5th power, which is 3,125. I need to multiply that by -4, and then I need to multiply that by 6. So that's -75,000 x to the 5th. Now I need to do 5 to the 4th power, which is 625. I need to multiply that by -4 squared, so 16. So 625 times 16. And then I multiply that by 15. And that's 150,000. So positive 150,000 x to the 4. 5 to the third is 125 times -4 to the third is -64. And that's -8,000. And I'm going to multiply that by 20. That gives me -160,000. 5 squared is 25. I'm going to multiply that by -4 to the 4. So times 4. 4 and then I multiply that by 15, should get positive 96,000. Now I'll have negative 4 to the 5th, so, which is negative 1,024. Multiply that by 5 and multiply that by 6, and you get negative 30,720 x. And then negative 4 to the 6, so 4 to the 6, 4,096. So my answer is 15,625 x to the 6 minus 75,000 x to the 5th plus 150,000 x to the 4th minus 160,000 x to the 3rd plus 96,000 x squared minus 30,720 x plus 4,096. All right, guys, thanks, and have a good day.